Capacitance of the cylinder. If you have a if you have a two okay, inside inside the cylinder is a positive charge and outside the cylinder is a negative charge. This is a Gaussian surface of radius r. Inner cylinder has okay. This is S1, this is S2. S2 charge, S1 cylinder is positively charged from the outer surface of the surface, and outer cylinder S2 is negative charge from inside the surface. Okay, so you have a two cylinders, S1 and S2. But blue cylinder is not a cylinder, it is actually a Gaussian surface we have considered, and here is the point P where we are interested to find the electric field. Okay, this point P. Okay, as I already explained, yes, so electric field will be a since electric field due to cylindrical charge distribution will be cylindrical symmetric therefore we will consider cylindrical Gaussian surface surface passing through point P, okay, as we have discussed in the previous case. Okay, so this will be a cylindrical symmetric, so that means we have to consider the Gaussian surface cylindrical. And yes, and there will be no change, and this Gaussian cylinder, this cylinder and this, and and potential will be same for on all points on this cylinder. Mean if point P is here, anywhere on this cylinder, the potential difference, because I have already explained, it will be treated as the equal potential surface. Okay, because it is the equal potential surface, and so the potential will be remain the same for all the surface. Okay. Because I have already explained for spherical charge distribution, that will be we have to consider the spherical surfaces will be equal potential surface, because that will be a spherical symmetric. For cylindrical, the cylindrical surface will be a equal potential surface. Mean the at every point, because E will be normal to the in this is the last lecture is about the equal potential surface. If you may recall that. Okay, and equal potential surfaces are that surfaces for which there will be no change in potential. Okay, so if point P is anywhere on this cylinder, there will be no change in potential. Therefore, the potential difference will be a 0. Okay, but if we move from S1 to S2, if point P is close to the inner surface, then potential will be higher. When it moves to the S2 negative negative charge cylinder, then potential will be a decrease. Okay, so the change in potential will be occurred when we move from S1 to S2. So change in potential will be occurred when move from S1 to S2. सिलेंडर 1 से सिलेंडर S2 तक. Okay, so or delta phi will be changed. Delta phi represent the potential. Okay, R1 से R1 to R. Okay, yes. So so delta phi, its mean delta phi will be equal to minus E dot dl, and that must be from R1 to R2. Okay, you may say that that is minus E dr R1. I have already explained dl cos theta is equal to dr. Okay, that is formula. Delta phi is minus E dot dl. Okay, जी नहीं, माइनस आएगा. Okay, so this will be equal to this. but electric field will be only due to S1 inner charge cylinder, because no electric field at point P due to S2. As I have already, because S2 is outside and point P is inside, okay, and charge P is not including the cylinder, okay. So that's why we have to consider the inner shell only, okay. Yes. So E will be Q, total Q, 2 pi epsilon naught R. R is the radius of inner, sorry, R is R, L, Q is charge on the inner shell, okay. Yes. R1 to R2 dr, okay, got it. And minus R1 to R2, sorry, Q is total charge on the S1, Q is total charge on S1, and it is constant when we moving the Gaussian surface from S1 to S2. Q is total charge on S1, and it constant when for and it's constant for R when R is moving from, हम पोटेंशियल डिफरेंस कहां से ले रहे हैं S1 से S2 तक, और जब R जो है जो गॉसियन सरफेस है, if it is moving from R1 to R2, Q will remain constant, okay, and it will be remain the constant, so it will become out the sign of integration. This is total charge on cylinder. The motion when we move from S1 to S2, but it will not affect on the total charge. So I have already explained electric field will be considered only due to S1, because according to Gauss's law, the electric field will produce only due to the charge enclosed, as we have done in the case of electric field. The outer surface will be not considered. The charge due to the, yes, so only the charge will be considered due to S1. That's the reason, okay. Got it? As it is the same case is discussed in the spherical charge capacitors, okay. So E will be minus Q 2 pi epsilon naught. The length of cylinder is constant, L, R1 R2 dr over R, okay. If we move from A to B, 2 to 3 or 3 to 2, what will be the difference? Result will be same, but sign will be changed. Okay, if we move from R1 to R2, that if integration is always along the line. Okay, if we move from R1 to R2 on the same line, and if we move from R2 to R1, the change in sign. So we may replace this Q over 2 pi epsilon L R2 to R1 dr over R. Why? Yes, why? Yes. dr over R. If you are moving along the same path, if you are moving from R1 to R2, if we change the path, that will be a R2 to R1. Yes. Mhm. You are right. R2 बड़ा है, R1 छोटा है. Whatever the depth, that is, if difference is -3, that will become a +3. If difference is +3, then that will become a. One minute. dr over this is equal to this. Why? 4 minus 2, 1. Okay. You want to say that 4 minus 2 is equal to -2 minus 4. Excuse me. 4 minus 2 is equal to 2 minus 4. That's the thing. Okay. Or if you are saying that this is 2 minus 4, okay, this will be equal to 4 minus 2. What is that answer? That depends upon the answer. Yeah, so that's. Now got it? Okay. If there is no power on the integration, okay, if there is no power on the no power on denominator, and this function and at nominator there is a dr, that will be equal to 1 over r dr is equal to log of r. Okay, you have to remember this. Okay, so E will be equal to natural log of r. To the integration of the result of this integration. Okay, you okay 2 pi epsilon L log of r. Value change from R to R1. Yes? And sorry, this is not E, this is delta phi. Sorry, this was a delta phi. We was using. This was a delta phi, please be correct. Okay. Okay. 1 minute. Q2 pi epsilon L log of R1 minus log of R2. Yes? And this delta phi will be equal to Q over 2 pi epsilon L, and this will be equal to R1 divided by R2. This is mathematical formula. Yes? Okay. And what will be the C? C is Q over delta phi. Okay. So C will become a Q divided by Q log of R1 R2 2 pi epsilon L. Q will be cancelled with the Q. 2 pi epsilon L over log of R1. So this will be the capacitance of the capacitor. Okay, got it?